In this video, we're going to look at optimizing areas and perimeters. So we're going to start by maximizing an area with a fixed perimeter. So suppose you have 24 sections of fencing and wish to enclose a rectangular garden. What is the maximum area you can enclose? So let's look at some different dimensions for this garden. Let's say we choose a width of 1. Remember, we have 24 sections of fencing. Then we're going to have to minus 2 from that because there'll be 2 widths of 1, which tells us we have 22 sections left over. Therefore, the length of this garden would have to be equal to 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because we have 1 piece here, 1 piece here, 11 here, 11 here. That gives us 22 pieces of fencing. So we're saying our length is 11, our width is 1, and if we try to find the area for that garden, 11 times 1 tells us the garden's area is 11 units squared. Let's look at the next set of dimensions. Let's say now we go 2 units wide. So again, we have 24. We need 2 units on the left, 2 units on the right. So that means we're going to take away 4, which means we're left with 20. So this has to be 10 units in length. So that would go to here. There's 10. So what we have is 2 wide, 10 for our length, which adds up to 24. So this is 10 by 2, which tells us we have an area of 20, which is larger than 11. Next one. Say we choose 3. We'll get 3 on one side, 3 on the other. So again, that's 24 minus 6, which gives us 18. And if we divide that by 2, that means we're going to get 9. And connect them here. So we have 3 by 9 for our garden. So 9 by 3, which gives us an area of 27 now. Next will be a garden that has a width of 4. And we have 4 on each side. That's going to mean that the other side is going to have to be 8. So there's our 4 by 8 garden. And if we add that up, that gives us 24 pieces of fencing. And in that case, we get a garden that's 8 by 4 units, which is 32. And then the next one then is going to be 7 by 5. So we can check that out. So there's our length of 7 by 5. That gives us an area of 35. And again, if we count up all the fencing we used here, 5 and 5 is 10, 7 and 7 is 14, so the total number of fence pieces we used were 24. And then the next one is going to be a 6 by 6. Which gives us a square. And that one we see has 36. And then you'll see the next one you're going to get is 5 and 7, which is going to give us 35. And we've already done a garden that's 5 by 7 right there. So those two are the same. And we can see that to get the maximum area, we'd need to have a garden in the shape of a square. So to obtain the maximum area of 36 square units, we need to construct a garden in the shape of a square with dimensions of 6 units by 6 units. And that's going to be true of all cases. If you're going to maximize the area with a fixed perimeter, a square is going to give you the maximum area. What about if you want a perimeter with a fixed area? So suppose you want to build a patio with 36 square patio stones. What is the minimum perimeter the patio can have? So let's start with the simplest case. Let's assume we're going to have a width of 1. So we're going to have 1 stone. And we have 36 of them, so we're going to keep on adding these stones. And that's going to give us 36 stones for our length. So if we have one here, if we want to find the perimeter, that's 36 on this side, and that's one on this side. So we have, remember, perimeter is the distance around the object. We have 36 plus 36 plus 1 plus 1. So our length is 36. And remember, our formula for perimeter is 2 lengths plus 2 widths. So we have 2 times 36 plus 2 times 1, which tells us we have a perimeter of 74 units. All right, let's check the next one. What if we go to a width of 2? So now we put 2 stones down at a time. Remember, we have 36 stones in total. So if we were to lay them all down in pairs of 2, we'd have 18 rows of stones that are 2 stones across. So our width would be 2, our length would be 18. So our perimeter would be 2 times 18 plus 2 times 2, and that would give us 40 units. Next one would be 3 across. And this time if we go 3 across, to get up to 36, we would need 12 rows of 3. I'm not going to draw them all out. But again, we would need 12 rows of 3. So we have 12 and 3. So we do 2 times 12 plus 2 times 3 to get our perimeter, the distance around. And in that case, we end up with 30. So you can see our perimeter gets smaller as we get closer and closer to the shape of a square. So we've now done 12 and 3. So the next one is, let's go to 4. 1, 2, 3, 4 across. So there's 4, 8. So this time we're 4 across, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 for the length of this. So we have 9 by 4. So that's 2 times 9 plus 2 times 4. So it's 18 plus 8, which gives us 26. All right, the next one, of course, would be 5, but 5 does not work nicely into 36 squares, so 5 won't work. So the next one is 6. So now we've got 36 stones arranged in a 6 by 6 pattern, so a square. We have 6 here and 6 going this way. And that means we have a length of 6, a width of 6. So 2 times 6 plus 2 times 6, that gives us 24. And then if we start going the other way, you see we're going to end up with 4 and 9, which we already did, is 26. And then 3 and 12, which would give us 30. So you can see that get the minimum perimeter or distance around an object, we need to have a square. So to obtain the minimum perimeter of 24 units, we need to construct a patio in the shape of a square with dimensions of 6 units by 6 units. So notice, again, we have a fixed area, so we have 36 stones. To get the minimum distance around those stones, maybe you want to build a fence around them, so you want to save some money, you need to put it in the shape of a square. Similarly, suppose you have 24 sections of fencing and you want to maximize the amount of space, we need the shape of a square. All right. So now with that information, what are the dimensions of a rectangle with a perimeter of 20 and a maximum area? So to answer that, we know now to obtain the maximum area, we need a square. And in this question, we're given the perimeter. Remember, the perimeter is equal to 2 lengths plus 2 widths. But since this is a square, we know that the lengths are equal to the widths. So if we draw a square, that all 4 sides are the same, so we can call them all lengths. So the perimeter is in fact just 4 lengths. So since we're told that the perimeter is 20, we have 20 is equal to 4 lengths. So if we want to know what 1 length is, we divide by 4. Right? If we want to solve the equation, we divide both sides by 4. And this tells us that we have a square with a length of 5. Since the question asks what are the dimensions of a rectangle with a perimeter of 20 and the maximum area, we now know the dimensions are 5 meters by 5 meters, but recall the area of a square. The area of a square is just length times width, but in this time it's just length times length, or if you like, the length squared. So the area of our object is 5 squared, which is equal to 25. Therefore, the dimensions that give us the maximum area of 25 meters squared are 5 meters by 5 meters, the length times the width. All right, let's try one more. What are the dimensions of a rectangle with an area of 45 and the minimum perimeter? So if we want the minimum perimeter, we need to get the shape of a square again. So this time we know the area. So recall that the area of a square is length times width, or in this case, length times length. This time we know the area is 45. So if I want to find the dimensions that work, I need to square root both sides of this equation. And if I square root that, I get the length is approximately equal to 6.7 meters. So we know the dimensions will be 6.7 by 6.7. So we have the area, we have the dimensions, all we need now is the perimeter. Remember, the perimeter is 2 lengths plus 2 widths, but for a square, it's just 4 lengths. So it's 4 times 6.7, which tells us we'll have a perimeter of approximately 26.8 meters. So therefore, the dimensions that give the minimum perimeter of 26.8 meters are 6.7 meters by 6.7 meters. And there are some questions you can try. Good luck.